Thank you for the introduction. Good afternoon. So I'm going to present the PPR Exploratory Molecular Archive, which is a French French project for designing an end-to-end DNA storage solution. So what is it exactly? So this is a program overview. This project was launched 3 years ago in 2022. And the goal is to focus on molecular-based data storage and processing. So we want to design a new device for massive storage on molecular media, so DNA polymers or non-DNA polymers. So we are, it's a French project, so it gathered 20 laboratories in France and around 60 researchers. We are considering all the skills that we need for doing the DNA data storage. So we are including some chemistry, biology, physics, and computer science. So this project is funded by France 2030, and we have a budget of 20 million euros over 7 years. And CNRS is the leadership of this project. So what is the main objective of MoleculArXiv? As you know, we have to face with the growing of the digital data over the world, and we want to be able to write on DNA very fast. So we have to develop new synthesis solutions that are fast, and in this project, we are targeting an acceleration of 100 for 100 times. And we are also, with our partners, we want to do some experiment and to store, at the end of the project, at least 10 gigabytes of data in 24 hours. So this project is structured around the 4 targeted projects. The first one is about next generation DNA synthesis, and is led by Yannick Rondelez, and was led also by Anthony Genot, sorry. So this project is focused on the DNA synthesis and the acceleration of the synthesis by building new solution for doing so. We have a second project which is targeted project 2, TP2, and the goal is to convert digital data to DNA. So the project is led by Pascal Barbry, Dominique Lavenier, and myself. So the idea is to develop encoding and decoding technology able to convert bits onto DNA, to be robust, and also to be adapted to the synthesis method that is developed in the first targeted project. Then there is targeted project 3, which concerns new polymers as an alternative. And this project is mainly prospective, because there is a lot of things to develop to be able to do such kind of process. And so the idea is to create new digital polymers to be able to store information on it. And in that case, we will be able to store more than 2 bits per nucleotide. And then the last project, TP4, is making DNA storage a practical reality. And so the goal here is to make DNA storage accessible and scalable, and we want to do some proof of concept with our partners. This ecosystem has been reinforced by 3 new projects this year, mainly 2 projects around non-DNA polymers, and a third project here on DNA polymers, and which focus on the parallelization of synthesis. So what are the key advancements? So this is a roadmap over 7 years for this project. And of course, the first idea of this project is to gather the French community around DNA data storage. And we are organizing some international workshops and also a summer or winter school. So we organized last year a workshop, which was not international yet, but which was over 3 days. The first day was open to the community, and the 2 other days were focused on the activity on the PEPR, only with people from the PEPR. But the idea is to organize and to make this workshop international, and next year we will have a workshop that will be open for the international community. And we are also organizing some summer and winter school, and we have scheduled a school in November this year. Also in the roadmap, and of course the goal is to develop technology, and we have some milestone here for producing acceleration of unique bit parallelization, and then at the end of the project, the proof of concept with our partners. So, of course, I guess you know, all of you know this 5-step encoding process. So we have encoding, synthesis, storage, reading, and decoding, and we are addressing all these steps in our project, and some work package are working on the encoding, DNA synthesis, storage, and etc. So I will highlight now a bit what we are doing and what are the first results of this work package, the public results, of course. So for the TP1, the idea is to create new chemical building blocks and to assemble the chemical building blocks. So they are working on new solution for accelerating the process. And of course, we have to miniaturize this and developing also microfluidic circuits to be able to have some miniaturization of the synthesis and to use less reactive. And also integrate this new chemistry into a complete process. So this means that this acceleration of the synthesis will introduce, of course, errors during the synthesis and the writing process. So we have to take into consideration these errors and be able in the complete process to correct those errors. The second, in this project also we have some platforms, a new platform that has been created, and especially at Gulliver in SPCI Paris and Institut Pasteur. So with a platform on high throughput evolution of polymerase, so we are able to demonstrate some solutions. So the second project is from digital data to synthetic DNA. So this is a classical workflow of encoding. So here we are considering what we have to do for encoding and decoding and robust storage decoding. So we must be able to evolve with the biochemical processing advancement, and especially what they are doing in the synthesis work package. And we are developing new DNA dedicated algorithms for error correction, for optimizing compression, especially image compression. And we are very active also in the JPEG DNA standard, which aim to release a standard in 2026 for image compression on DNA. And also we are processing high throughput sequencing data and working on the 3rd generation sequencing for being able to manage terabytes of data after sequencing. We are also working on random access by molecular addressing with 3 main activity on DNA caching, which allow to retrieve easily the data that are frequently accessed. We are also designing primers for for random access. And also we are designing long molecules to be able to store more information in an oligo and to facilitate also random access. So we have also platforms in this project, the UCA genomics platform at Université Côte d'Azur for specialized in genomic, in sequencing. We develop several tools also for what we are doing in information technologies, and we are contributing to JPEG DNA. So the third project is new polymers as an alternative. So the goal here is also to accelerate the synthesis, but in that case it's for digital polymers, so it's relatively prospective. And also one of the main points is to retrieve information by doing sequencing, which is not obvious, so they are working on this topic also. And a project also that started recently is erasing and rewriting information, and the idea is to be able to read and write and to erase information directly on the polymers. And finally, the last project, which is a, let's say, application project, and we want to implement proof of concept. We have 3 institutional partners, Institut National de l'Audiovisuel, so INA in France, the European Parliament, and the software heritage. And some first experiments has been done with software heritage. In this project, so the goal is mainly to develop end-to-end proof of concept by the end of the project, and we are also working on cryptography and molecular computation, and we have 2 satellite projects that started recently on these 2 topics. So the goal of MoleculArXiv is to connect people, industry, and the world. So we are for that we are organizing workshop. And we have also some partners. So currently we have the 3 partners, but we want to enlarge the partnership with end users. We launched an activity, DNA data storage working group with what we call CNRS GDRIASIS. It's a French institution for research. And we are currently organizing 2 events, so the Autumn School and the second workshop. We have also in our project created a MoleculArXiv working group focused on transfer and innovation. So the idea is to see how we can transfer the innovation that is done in this project to industry. So the idea is not to wait for the end-to-end product for looking at a transfer, but to try to transfer some innovation during the project. So we are working with this new group to do so. And of course, we are participating to the alliance. We are doing standardization efforts, and we are trying to push this project to a European flagship project. So publicity for the school in autumn, which will be held in Cargèse, Corsica, France. So we have the QR code here if you want to access to the website, and if you want to submit a work to participate, mainly open for students and postdocs and researchers also that want to be involved in DNA data storage. So my last slide, and it is what I wanted to say about this project, is, okay, what is the role of MoleculArXiv in shaping the future of DNA data storage? So the futuristic vision, I guess you all agree about that. It's a DNA will be an ultra-dense and sustainable digital storage integrated in the everyday take, and with active molecular computing, search, retrieval, processing. And the idea is also to design shoebox-sized data centers. What I mean is at least data centers that takes less space footprint than today. And also random access and read and write, DNA read and write. So this project I'm leading is contribution around building scalable and affordable DNA synthesis and sequencing system, and also trying to accelerate this process of synthesis and sequencing, so the writing and the reading. Develop innovative molecular encoding solution and compression and error solutions. We address the whole chain with biochemistry and information technology. And also, why not develop this new kind of storage based on non-DNA molecules? Develop microfluidic solution for high throughput molecular data access. And driving IP strategy and standardization, of course, to enable a broad adoption of the solution. And so that's it for my presentation. Thank you for your attention.
Thank you. It's a very involved program. Is there any questions by anybody concerning this? David.
Mark, you talked about a target of 10 gigabyte cold archive in 2029.
Yes.
And the previous presentation from BioMemory said they were doing a petabyte in 2030. So that's a big difference in terms of orders of magnitude. What am I missing here?
Well, what we are trying to do here is to develop new synthesis solutions. So we develop a new chemistry for accelerating the unique bit writing. So this is very prospective. So so it's for a unique bit. Then we have to parallelize that, and to parallelize, we have to develop new electronics for doing the parallelization, for the acceleration. So we have to start from scratch. I mean, for the synthesis and for the parallelization. So what happened is that, okay, in the targeted project one, people are working on that unique bit acceleration, and it's a work of Yannick Rondelès here. And we have to parallelize that, so which is not obvious. So 10 gigabyte is the target. Maybe we will do less or more, but as soon as we will be able to develop and to make these two things working together, we will be able to accelerate. So probably the difference between what people target today with existing or on-the-shelf solutions and what we are developing from scratch. I don't know if it's answering your question correctly, but...
Last question, different question would be, are there opportunities for non-French parties to participate in your work?
Non-French people participating? Yeah, well, it's a French project, so we have, of course, some researchers that are working in our group that are not French, but working at CNRS or university in France. And we are collaborating with people outside, but it's a matter of how we can dispatch the funds, and the funds are dispatched between French researcher or French labs, not French researcher, but French labs.
Can you comment on the EU activities? So you mentioned this partnership or flagship program. What are your plans and activities?
Okay, well, we are trying to build such kind of project. We are starting, but we don't have any. We were in discussion with CNRS in Brussels for that, but we don't have any today strong activity in building such kind of project. But we will. It's in our plan, and we want to do that.
But what is the vision? Is the vision to create such, like Mission Cancer or such a larger framework, or?
We want to gather European labs that are working on the topic to be able to develop, maybe MoleculArXiv will be a starting point, and then we want to enlarge this project to not only a French community, but a European community, and why not international, but at least European, because the main, let's say, the main objective that was, and that is the objective of CNRS and French government, is to build a sovereign solution. Sovereign, I mean a European solution for DNA data storage. So.
Anybody else with a question?
Thank you. So we have several questions online. So the first question is about the modified nucleotides. Do you use modified nucleotides to address the biosafety concerns?
The biosafety?
Yeah.
We are not addressing right now biosafety, so...
Not that much, okay. And the second question is linked to this first one. It's about the optimized DNA polymerases. Will these optimized polymerases will be able to use the modified nucleotides as a substrate?
What do you mean by the beginning of the question? Sorry, I missed.
Actually, I'm not sure to understand, but in your presentation, you mentioned you were working on modified nucleotides.
Yes.
And the question is, you are also developing optimized DNA polymerases, and the question is about these DNA polymerases, if they are able to use, for instance, new substrates for instance, to amplify the DNA or...
Well, I basically don't know. It's not in my skills. Maybe
Yannick
is one of the leader of the chemistry part. I'm from IT, so it's a bit difficult for me.
So yes, for the person asking the question, so I am Yannick Ronlez, in charge of the work package 1, and the answer is yes. The polymerase and the modified nucleotides are co-developed to be adapted to one another.
Any other questions? Okay, well then, thank you very much, Mark.
Thank you.
We will end our session for the morning.